Okay, so we're back, and what we're going to do now is we're going to talk about more rigid motions, but this time what we want to focus on is recognizing what type of rigid motion took place to obtain a certain image. If you see this drawing here, this is the original and this is the image. The original is in green, and what I want to do is find the reflection line used to obtain the image from the original. So this image was obtained from reflecting the original on a certain line, and I want to find that line. But before that, I want to show you how I know that a reflection was used. That is, let's forget that I told you that it was a reflection. So how can you know that what I applied was indeed a reflection? So as you can see, the original is a concave hexagon, which I'm going to call now staple. Okay, the orientation of this concave hexagon is clockwise. If you see, if I am spelling the word S-T-A-P-L-E, I'm moving my pencil the way that the hands of a clock move. Staple, staple is a clockwise orientation for the figure. Now, this one I know is the image. And since this is the image, then this point S ended up here. I'm going to call this one S prime. T then must have ended up here, T prime. A ended up here. P clearly ended up here, that's the P prime. L and E, E prime. So as you can see now, I have S prime, T prime, A prime, P prime, L prime, E prime. I got a staple prime. So when I spell staple prime, the orientation that I get is counterclockwise. So the original has clockwise orientation and the image has counterclockwise orientation. That means that the rigid motion that was used was either a reflection or something that we call a glide reflection. But in this case, it's just a reflection, and I'm letting you know that that's the case. So I want us to find the reflection line. So now we have to remember that if you have watched the video when I show you how to reflect the figure on a line, the reflection line is always the perpendicular bisector for a point and its image. So that means that the reflection line should be the perpendicular bisector for the segment that joins A and A prime. The perpendicular bisector of A and A prime is then the reflection line that I'm going to use here. So I'm going to show you how to find that reflection line using a compass and a straight edge. So to find the perpendicular bisector of a segment, all you have to do is use your compass and put the sharpened end on one of the points in the segment and the pencil on the other end of the segment. Then you draw an arc like I'm doing here. Switch, and you put the sharpened end on the other point of the segment, and so the pencil is now on the other point of the segment. You also draw that arc. As you can see, the two arcs that I drew meet at 2 points. If you draw the line that if you draw the line that joins those 2 points, that is the perpendicular bisector. So in this case, let's erase everything. That we did. Now you can see for yourself that indeed the line that I just drew there, which was the perpendicular bisector of segment AA prime, is indeed the reflection line for this figure. As you can see, it's the mirror image for those two.